Hello and good evening everyone. It seems I'm starting on time, this hasn't happened for a while now. So I'm back after vacation and it seems I'm also back to streaming, at least in English, since I still postponed the Polish one since I have some other plans for the day. So there won't be a Polish stream tomorrow, I'm sorry about that. There will be normally an English and a Polish one next week. At least I hope so. But I think it should be. Yeah. Anyway, so okay, question number one. Why is my preview lagging? That's okay. Well, maybe it'll be fine in a second. Cool. So the topic of today's live stream is going to be the Google CTF. It happened during the last week, and well, I had some involvement in it. As some of you may know, I work at Google and in one of the security teams, and actually our team got to organize the CTF this year, and it was actually mostly organized by different people than last year. That's why the difference in approach to the tasks, probably, as some of you may noticed. And I was basically responsible for the reverse engineering challenges, which means I didn't create all of them, I created only one of them, but I did, well, basically test all of them, so I'm pretty familiar with them and I can talk a little about them. Basically, I guess I'll jump back to this topic in a second. Now the usual announcement, KrzaQ here, well, I shouldn't do a thumbs down, maybe I will point here, is my moderator today. Thank you for being here. If you have any questions, guys, actually folks, then just ask him and he will let me know using our magical, well, voice chat. Yeah. Okay, now the usual stuff. Let's jump to this. This is KrzaQ's website and it's dev.krzaQ.cc, and he actually promised me that he will write an English post soon. Well, didn't promise, but he did mention. So yeah, basically subscribe to his blog. New content should be coming soonish. Then before I jump here, I actually will go through my usual mentions. Live Overflow CTF is the YouTube channel you probably want to subscribe to, since it's, if you're interested in security basically, and in CTFs, and especially into low-level stuff like hardware or exploitation, totally like check out his channel. And yeah, like subscribe here. Also, another person has been streaming recently, that would be Murmus CTF. Totally check out his channel as well. He's well, started, I wouldn't say recently, it has been like a month or 2 or 3 already, so I also recommend subscribing his channel. And yeah, now jumping back to the missions. As you know, each time after the live stream, I publish a mission, and the mission is basically a small CTF-like or programming task. And last time, that was what, 3 weeks ago, I believe? It was mission number 5. And mission number 5 was all about a picture. Now, if you actually went to this picture, the browser would show you like a broken picture icon, so like the browser couldn't interpret it. Now, if you would actually look at the HTTP packet which was sent, you would notice that it's, well, there are some weird stuff here, like you don't usually see content encoding RLE. RLE standing for run length encoding, and it's one of the simplest compression algorithms out there. And then content type image/raw, and then like some additional arguments being probably the width, the height of the image, and bytes or bits in this case per pixel. So this is quite unusual, but quite easy to understand and to interpret if you actually know what pictures, how bitmaps are transferred. So yeah, and how does run length encoding work? Well, it's basically like, it's pretty natural, right? If you see the string like here, you wouldn't say, oh, the string is A, B, B, C, C, C. You would say it's 5 A's, 2 B's, and 3 C's, and this is exactly run length encoding. You just say 5 A's, 5 A's, 2 B's, and 3 C's. So yeah, that's all there is to it, basically. You usually have 2 bytes, and one of the bytes, it sometimes might be like reversed, right? But usually 1 byte is the repetition count, how many bytes to repeat the next byte, and the second byte is just the byte to be repeated. So yeah, and to decode it, you know, like you take 5 as the number and A as the byte, and you write A 5 times, and so on and so on. So that's not exactly what I wanted. So yeah, so when it came to the file, it was exactly it. Like you had how many and then what byte, and so on and so on. And if you write a decoder to it, you could get the image itself. Now the image looked like, I actually don't remember how the image looked like. Let me find it. Oh, no, that's a different way. I actually don't have the usual shoutouts, so let's go to the YouTube comments section and see who solved it and see if somebody posted the decoded one. Well, mission number 6, this is actually a typo, it should be 6 here. Mission number 6 will be published after today's live stream. And it's, I think, the hardest one yet. It's not super hard, but it's the hardest one yet. Okay, so I think D-Line was actually the first one to submit the correct answer, which was who runs this encoding. And he also submitted the write-up on his GitHub. Let's check it out. Let's see if there are... Oh, nice. It's a real write-up. So thank you for posting write-ups. I'm always happy if somebody posts like a blog post or a write-up of a full solution, because if somebody, you know, is more newbie, just starting with hacking, they don't really know how to approach every challenge. They might try, but sometimes they fail, sometimes it works, but sometimes they fail. So when they see a write-up, read through it, it's really like beneficial to them. So thank you for posting this. Okay, and do we have the final image? Yes, it was actually, well, I actually made a picture with my cell phone of a piece of paper which I've written this message on and then encoded it this way. So yeah, well done, well done. This is exactly how it should look like decoded. Perfect. Let's so D-Line was the first person. I will finish the slides and post them in the description of this live stream after the stream. So yeah, nothing lost. Then Hastur, I think, should I read this as an A or is it H4 Stur? I'm sorry, I don't know, but this person is the second person who actually got it correct, and also has a write-up published, which is really awesome. Yeah, it's a little different, and the colors are reversed, but that's to be expected actually, so that's fine. So well done, and thank you for posting the write-up. Again, I'm always really happy when people post write-ups to it. And I think at least one more person solved it for some reason. I don't see it. I don't know why. Maybe it's still in my moderator queue, but I think there was one more write-up. I'm going to include it in the slides if it shows up. So congratulations and thank you for taking part in my missions. Now, let's go to some random news before I jump into the CTF tasks. I honestly don't know how many CTF tasks I will be able to do today. Probably 1, maybe 2, maybe 3. Depends on if I want to show you the details or just jump through the task. So, Yuru was on Recon in Montreal. Recon is the reverse engineering conference. It's one of the best, if not the best, reverse engineering conference out there. And I'm not saying that just because I presented there some years ago. It's actually awesome. And awesome people show up. And he published his his research related to Bugspawn. Bugspawn is basically an emulator-based automatic vulnerability finding system, which initial version was developed by myself and Yuru, but then he took the research and moved it forward, and I jumped to our project. And he found a lot of more bugs, so totally check out his blog post, check out his slides, it's awesome. I'm going to give you the links on the channels. So that would be 1 and that would be 2. And the other big news actually this week is the Quals released the Stack Clash. The Stack Clash is a number of vulnerabilities found on the Linux applications, which are basically vulnerable to the so-called stack clash, or actually stack exhaustion. The way it works is like this: I'm actually going to spend a while and explain it because it's actually awesome. So this isn't the first vulnerability of this kind discovered, but they're super rare. Like the last vulnerability I know of in Linux was discovered 2008-ish, so that's like 9 years, and that's a long time. So there's usually in memory. Let's assume this white space is memory, right? You have a stack, and then there's like the stack might be, let's assume it's not fully allocated, but then there is. So it's allocated up until here, and then there is, this is the not allocated region, which will be allocated, and then there is a guard page, and the guard page is here to basically separate the stack from the heap. Here we have the heap, and the heap is growing like basically this way, right? Now, if you start doing stack recursion, you know, like calling a function recursively, for example, right? Well, it will have the first stack frame here, then the next one will be here, the next one here, the next one here, then here. At this point, it will start allocating the memory and here, and so on and so on. And if it would be an infinite recursion, or the number of recursions would be quite high, depending on the stack size, of course, then it would reach a place where it hits the guard page, and, well, the program just crashes, because the guard page is there to crash the program in such case, which is the correct behavior, and that's good. Now, the problem begins if you actually have your stack frame isn't this size. It's actually like this size. Like, look at the length, right? And then you allocate the second one, and it seems that it bypassed the guard page. So if your heap was actually this size, for some reason, well, you had a lot of stuff allocated, then, well, this is the clash, right, of the stack and the heap in this case. And if the function would write, you know, local variables which are on the stack, it would actually overwrite the heap, which is in the same memory location. And this, in some cases, might lead to a remote code execution due to, you know, heap overwrite, or you might write to the heap and overwrite actually the return address for some reason. So all weird stuff might happen. And yeah, and Quals did an awesome analysis and basically discovered vulnerabilities in applications on like some Unix stuff and Linux stuff as well. So this is an awesome research. I totally recommend reading it. If you're, I guess if you're on the full disclosure on the mailing list, you know that there was a huge dump of links with these kind of bugs, I think 2 days ago or something, or 3 days ago. Or maybe that was like OSS security. Well, one of these mailing lists. Cool. So let's go to the Google CTF. I'm going to close this and close this. Now, let's see the scoreboard first. So Pastan from Israel, if I remember correctly, won it. Congratulations, well done. LCBC from Russia was next. Then we have a team from Asia. I'm sorry, I will not try to guess which country was that because my memory is failing me now. Congratulations, it was a super hard CTF. I think there was about 2,000 teams participating. I don't think I ever saw 2,000 teams on a CTF. Now, I know that a lot of people expected the CTF to be rather simple or have some entry-level tasks. And that wasn't the case, actually, because, well, I think it was... Oh, in the end, we said that it's probably something we have to do better next year. So next year we have to have the same amount of hard tasks we had this time, but also have some entry-level tasks, like tasks which normally have 20 points, 50 points, 100 points, just for people to enjoy the CTF as well and to learn something, because the level this year was really hard, and I would actually compare it with DEF CON qualifications in terms of how hard the challenges were. So we had the easy category, and some people argued that the easy category isn't so easy as we would like it to be. Since I actually need to log in, I'm going to use another browser. I'm going to use my browser. Here we go. So let's go to the challenges tab. Okay, perfect. We had some issues with infrastructure as well. We did tests. We did even have a test run CTF actually before it, but you cannot really test 2,000 teams participating without having 2,000 teams, and yeah, we have some stuff to do better next year. Anyway, let's start with the tasks which a lot of people solved and a lot of people complained about that it was guessing or you had to guess really hard. And my argument is, no, you didn't have to guess at all. So yeah, let me just open this task. Yeah, I guess this is all there is. Hello, what do you want to read? And it's called, by the way, Mindreader. I'm not even going to guess what Mindreader is. Anyway. So by my own browser, I mean a browser which is logged into my account, while the browser which I use while live streaming is not logged into my account, just so I don't disclose my, I don't know, history by accident. Yeah, anyway, so what do you want to read? Let's type ASDF, and it says not found. But I guess we can see here that this is actually a get parameter, right? So let's assume, well, we actually saw the name here, F. F usually stands for file, right? So without too much guessing, we can say that, hey, this is a file, and let's go to the standard file you always test, right? HTC passwd. Usually people test either on this file or on some other file. So yeah, we know it works. We know this is, basically we are given for free a file, and what's it called? Arbitrary file read, I think that's one of the names which is used for this kind of vulnerability. So we can give it a name of a file, and then it gives us the content of a file. So now we need to find the flag, right? And where is the flag? Well, the flag might be in file flag. No, it's not there. Maybe flag.txt. Not there. Maybe it would be like slash flag. No? No. So it's not there. I have no idea. And I'm not going to guess where the flag is, because usually when the flag is not in the file called flag, that means that the creator of the task wants you to actually be smart about it and not guess where the flag might by accident be. So okay, let's well, you know, if you don't know stuff, you have to learn stuff. And in this case, I would like to learn what is going on like in this challenge. And to do that, I need the source code of it. So how do I get the source code? Well, I have no idea actually how it might be like index.php, right? No, it's not it. So I guess I'm just going to read from proc, like proc self cmd line to check what am I dealing with. Sorry, cmd line. But that doesn't matter, it says forbidden now, so it changed. It said not found in that case, and now it says forbidden. So it seems that it's like I don't have access to either proc or proc self for some reason, or this file. I don't know which one is it. So I'm going to like start testing. I'm going to remove the CMD line here. Can I actually make it bigger? Yeah, I think I can make it bigger. Yeah. So I'm going to remove the CMD line. And if well, you can see it's still forbidden, right? Even though I removed the CMD line. So maybe this directory, I'm going to check if I have access to proc. It's still forbidden, but there's one mistake I'm making. Since I'm actually addressing a directory, it might be that if I address a directory, then it always says forbidden, and I always need to access a file, right? So instead of this, I'm going to type etc. I know etc is just etc. I know it's a directory, right? So, but it says not found. So that means it isn't really. Let me maybe go here. Yeah. So we now know that it isn't really. What? No, that was a mistake. Sorry, it isn't really showing forbidden on directories. It's showing forbidden on the proc directory. And there are two ways now. Like if I would be a creator of a website and I would not like my script to access proc, what can I do about it? Well, there are two things I can do about it, right? First of all is I can change the permissions of a proc directory, but usually applications kind of complain about it. So, so that's one thing. Another thing is I might not mount proc at all, which is possible. So that's the second approach. And the third approach is actually to go a level higher and filter this parameter. Like, don't interact with a file system, don't let the user interact with a file system at all, just filter this parameter. So I'm going to go one by one with these, starting with maybe, let's assume that let's assume that this is not mounted at all. So this actually doesn't exist, and that's why it says forbidden. So I'm going to change it to ASDF, which is a directory I'm pretty sure doesn't exist, but it says not found. So no, so I'm pretty sure it is mounted now, it's just banned for some reason. Now I don't really know if it's banned on the file system level or is it filtering this. So I can check it by, for example, going to etc/proc. And there is no etc/proc, but for some reason it says still forbidden. So maybe it's filtering actually the parameter. So let me do it like this. Let me maybe just put the string proc here, but I'm going to put some letters around it. And it seems it just doesn't like the proc string itself, just the string. I'm going to remove one letter, not found. I'm going to add the C back again, and it's forbidden. So yeah, I guess I need to find a way to basically bypass the, well, this, right? So how am I going to go about it? How do you bypass such stuff? Well, I guess there are a couple of ways. The easiest way would be to find a symlink somewhere on the drive which actually leads into proc. Now, you can use, for example, find on your, like find the command find on your Linux VM or your Linux workstation and start looking for it. I actually know where the link is, obviously. So there's a link. Let me maybe launch a, let me do this and launch a console. Okay, this is a Linux console. Now if we go to /dev, there's actually this link. It's called FD, and it's actually a directory link, and it leads into self-fd, which is a directory. And this is the language you should use. Now, if you don't know about this link, which I didn't, you just run find with -l name, proc with asterisks, and it will actually find it for you. Let me maybe show you the command just to... I'm not going to run it on my drive because it takes about 10 minutes, but... okay, so give me 3 seconds. I actually did just after the CTF, I did publish a write-up on how to solve it, so I have it noted down. Recent and... okay, here we go. I'm going to give you a link to the write-up as well in a second. Yeah. Okay. So, no. This is the command, right? Let me maybe do this. And so I'm basically looking for a link which leads into proc, and I'm doing -ls, which is basically listed. And then I'm removing all the links inside proc, since I don't want to look for links inside proc that lead into proc, because proc is banned for me, so the link has to reside somewhere else. And I'm going to just look inside dev. And there are a couple of links, as you can see. They're like stdr, stdout, stdr, stdout, and stdin. Then there's also core. All these are files, and it also finds this one. So this is the one which I should use. So let's do it like this. No, /dev, fd. And now, since I'm at this point, I'm in proc. Let me maybe make it bigger for you guys. I jump back to the previous directory, which is proc/self, and cmd line. This is what I was looking for, right? And it says here that it's actually Python, and it runs something called gunicorn -b something, and then there is conf.py, unicorn conf.py, whatever that is, and then there is main :app. So I have no idea what unicorn is. I didn't know before the CTF either. So if you go here, it seems to be a web server, basically, which is used in Python. And if you actually just look at this example here, which is run with a similar format of arguments, right? There's my_app, :app. It actually looks for my_app.py, so this is the name of a py file, right? So going back here, we now know that the file will be probably called main.py, so I'm going to just open this file, if possible, main.py, yeah, it's possible. So let's maybe show the source. And this is the source. And let's look what's actually going on here. So I'm going to again do this and do, yeah, zoom it a little better. So blah, 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 it does something. Then, yeah, this is what we are fighting with. This is the filtering of the argument. And, oh, yeah, it asserts if that the environment variables have actually a flag set in them. So, yeah, let's look at the environment variables. And given that just a second ago I was already in proc, I'm just going to like list environ here. Environ, which is, you know, proc self environ is where all the environment variables reside, the live ones, and the flag is here. So that's it, and that was the Mindreader task basically. So again, there was no guessing here, at least in my attempt, which I did, there was no guessing. I know some people did guess the main.py, and I think that's both helpful and unhelpful. So the helpful thing here is that if you guessed main.py, you didn't have proc bypassed yet, you didn't know about defFD, but you didn't know what kind of a filter is used, so that helped a little, I guess, and you did know that the flag is in the environment variables. If you didn't guess it, then you'd probably stumble on proc sooner or later. I mean, it's the obvious place to look into for details about the environment and so on, and it's usually the file where you look at. So yeah, I'm not sure if guessing main.py was a good thing or a bad thing. It depends, I guess. But that was the solution, and yeah. I guess KrzaQ says that there are some questions. I totally forgot about opening my side with the questions, so let me do it. Okay. So quickly switch here. Now, okay, if there are two questions, I'm going to go quickly through them. Have you done OSCP? What's OSCP? That probably answers your question, but no, I haven't. OSCP, it's Offensive Security Certified Professional. Oh, as heard, I actually don't do certificates. I don't have anything against them, I just don't do them. Yeah, so, yeah, I don't know. What about null byte poison? So that's actually a good question. It wouldn't bypass the... It's like this, and since it's Python, it wouldn't bypass the anything, because Python actually, when it detects the null byte poison, the null byte inside the string which is passed into file operations, it actually throws an exception, which is the correct behavior. Well done, Python. PHP does the same in the newer versions. That's not true for Java, if I believe correctly. So, but that's a good question. I don't think a null byte poison could be used here for anything, but I might be mistaken. Yeah. Usually you use the null byte poison to cut off something, cut off the extension, for example. And here you didn't really want to cut off, you wanted to bypass a string, you wanted to put your string there. So yeah, okay. Again, if you have any questions, ping this guy on YouTube or on IRC, and he will pass me the questions. So yeah, very good. And I will try to answer them in spare time. Let's go to my category, which is reverse engineering. Let's start with Johnny Boy. Johnny Boy was the easiest challenge here. It had 44 solves. Again, there were 2,000 teams participating, and an easy challenge had 44 solves. That tells you that the challenges were difficult. Now, food was actually solved more times and it's medium, and I will tell you why. Because Johnny Boy is a task where lazy people will solve it easily, and hardworking people will struggle with it, and I'll tell you why in a second. Let's start with looking at this. This looks retro but somewhat futuristic. I always lose those. Can you help me win? So we already know that the idea here is to help somebody win in probably a game. My friends solve it without IDA. Okay, this is a huge tip. It basically tells you no reverse engineering required. It doesn't mean don't run IDA, use binary ninja. It's not, no. You usually interpret something like this as no reverse engineering required. Be smart about it, be lazy about it. And there's also a link to a YouTube video. I'm going to go here, and as you can see, and I can hear, it's an Arduboy. An Arduboy is an Arduino-based console, which is quite interesting. I'm actually going to jump into the website, Arduboy. No, not this one though. Is my internet lagging today? That's unfortunate. Okay, and we can see obviously here one thing. It's not a color console, it's a black and white console. And if we go into the details, it's actually a pretty cool console, I like it. Yeah, we have the specification here, which is the most important part. First of all, Arduino compatible, which means AVR, which is the architecture, the ISA like instruction set architecture used by Arduino. It's run probably on some Atmega UC. It's not UC, it's micro C, microcontroller. Yeah. Atmega. Yeah. And it has 1-bit OLED matrix display with this resolution. This is actually important. Yeah, Atmega controller, as said, 16 megahertz. This is actually faster than my first PC and my first laptop, so don't laugh about 16 megahertz, okay? But my laptop did have more RAM. Yeah, my laptop actually had like, I think 640 KB. That was my first laptop, and my first PC had 1 megabyte of static RAM. Yeah, but my laptop didn't have 6 hours on battery. I think it had less. Anyway, so yeah, this is basically a toy console. Okay, so let's see what we get. What we get is actually, let me copy it into another directory. Here we go. I'm sorry, I need to load my config for, yeah, I didn't stream so long, but I actually don't have my, I forgot what things I need to set up before I can actually do the stream. I apologize for that. We get a .hex file, and there's like .ino thing. So the challenge, let's look at it in a hex editor, since that's the obvious way to do it. Well, this isn't really a hex editor, this is actually a text dump, a text file. I think it's called like Intel hex format or something like that. It's once you dig into it, it's pretty easy to understand. I think like the first n bytes are actually like the address, then you get the data, and then you get like the checksum or something like that. But you can convert this hex file into a binary using some tools. I don't know if object copy actually can do it. Object copy hex to win, maybe it can. Blah blah blah. Yeah, maybe it can. Let's try. Object copy comes from the GCC compiler pack, which means that you usually have it ready on your PC. So object copy. Now what then that or binary, and then asdf.bin, because I am lazy. But it cannot recognize the input format. Well, that's unfortunate. I'm going to try to load it into IDA then, because IDA also understands the hex format. And it actually did load correctly, so yeah. So we have it in IDA, that's something, because in IDA I can probably make some kind of a dump as well. Let's see what I have here. Dump IDC, no, maybe dump database to IDC would work. Anyway, I can just copy this part, and this should be fine, because I want it in binary format. Now, again, since I loaded it in IDA, you might notice there's no code here, but there are some strings. Strings are always nice to see. And let's just go here, let's click C, there is, I don't know, this. I think actually AVR has like interrupts there, so maybe that's not the correct. Oh, I think I didn't click one important button in IDA, which I'm going to correct now. I didn't mark that it's an Atmel, it's an AVR. No, I did it again, my bad. Yeah, so as you know, IDA actually shows you this window, and I need to select an AVR here. So Atmel AVR, perfect, set processor option, and Atmega, I don't know, 16, or what did the website say? It says 32, okay, 32 it is, here we go. Okay, IDA complained about something, but it did load it in the end anyway, so here we go. Now it's correctly loaded, and we have, yes, we have, this isn't Intel anymore, I think. Yeah, it isn't Intel anymore. So, a hardworking person would find an emulator and reverse engineer this AVR code. There is quite a lot of it actually, if you see. And when I got to this task, I was already after reverse engineering 2 tasks, spending like 10 hours on them or something. And I said, like, no way in hell I'm going to reverse engineering AVR now. So I basically fell back to what I usually do, is more recon, because you can't have too much recon. But yeah, and I decided, like, just to look around and see what can I find in the binary data. I figured out that, well, since this is actually a 1-bit display, maybe I will look for bitmaps, for assets, and, you know, for images, right? And to do that, I obviously had to dump this file, was the first thing to do. I don't know, can I do it in IDA in a sensible way? Columns, autos, okay, edit. I don't know if I can. Save to file, I would like to save it to file. IDA, please allow it to save me to file. No, this is RAM. Okay, what I'm trying to do now is I'm trying to dump it into a file. This isn't working the way I would like it to work. Yeah. This is better. So I'm going to just dump it into a file and then write a parser and whatnot. I copied it into... Oh, I can save it to file, perfect. Oh, cool. That's DEFCON qualifier stuff. I'm pretty sure it's going to just dump whatever I have selected into a file. Okay, perfect. No, IDA, you are awesome. You actually did a binary dump for me. I didn't know IDA could do it, but thank you. So okay, I have a binary file. Now I'm going to look for this stuff. And the important stuff here is this 1 bit. That means that actually if you have a byte, right? The byte has 8 bits. That means that I have to actually like separate the bits into bytes, separate bytes, and then I can look at it as an image. So I'm going to write a short Python script for it. Go.py, because why not? I mistakenly called it dump.txt expecting a text file, but it's not. So, sorry, read binary, obviously. I'm going to read it into a byte array. Oh, I know. I should actually make the font bigger as well. Apologies again. Okay, and that file. Now it's bigger. So I'm opening a file, I'm reading it into a byte array. Yeah, that's correct. And I'm going to basically like transpile it, convert it into an 8-bit per pixel bitmap. And this is actually going to be rather easy. C and D. Now for I in range 8, because we're 8 bits in a byte, I'm going to go like this. I actually don't know where... if the assets are sorted, I don't know if it's like least significant bit first or most significant bit first. It's usually... It could be anything, so I'm going to do both. So I'm going to shift 1 by I this direction, and is this correct? No, it's not correct. This direction, obviously. Then I'm going to OR it with C C is actually from a byte array, so it's just a number or slash character. That's okay. Okay, and O2 is actually going to be 7 minus I, so I'm going from the most significant bit first. So if I is 0, then it shifts 1 by 7, if I is 1, then by 6, and so on, and when I is finally 7, it doesn't shift 1 at all. Okay, and then I need actually two outputs, so out 1, which is an array, yeah, or a list, actually, that's a list, yeah. So if O1, then out 1 append, because this is either 0 or anything else, right? Because it could be like non-zero, it could be 80 hexadecimal, for example. I don't really want to deal with it, so I'm going to just do this. This is, if it's true, then do something. Then append a white byte, else append the black byte, black being 0, 0. I'm going to do the same with out2. Now the script isn't beautiful, but on CTF it doesn't matter at all. Now I'm going to write it into two files, right? So first is going to be called o1.raw, and I'm going to write binary, and what I'm going to write there is, well, the array I created, right? This join doesn't do anything, it just like converts a list into a string, but that's all it does. So that's 1 and that's 2, and I can now run it. So python go py done, and I have actually two files here now, which are of this size, and they now what I do is I can either choose GIMP or I can choose Irfan view. I'm going to go with Irfan. No, I'm going to go with Vimp. I'm actually going to rename these files or make a copy of them called data, because data is actually the extension which I have associated with GIMP. So yeah. Okay, and I'm going to start with O2 due to random reasons. GIMP is loading. Yeah. And here we have the file. Now, what do we do now? First of all, it's not RGB. It's going to be grayscale. So it's indexed. I'm sorry, I have a Polish version of GIMP for some reason. So it's indexed, and it's, as you can see, it's like black or white because that's what we created. Now, the width is actually 128. And I can see something here, but this is not readable. But I think this is a C here, right? So yeah, this is probably a C. This doesn't work like it should. So it's not readable because I probably shouldn't go with the O2 file, which was again the most significant bit first. It was probably the least significant bit first encoding of a byte, which means I have to load the other file, the O1 file. So again, indexed, then width is 128, and did I misclick? Because this is the same thing I saw earlier, but you can see the letters, you could probably decode it, but probably misclicked. Probably wanted to start with this one. Or maybe, no, I know what's wrong. When this is happening, it usually means, yes, a typo. This is a typical copy-paste error. When you copy-paste something, you have to be super careful not to forget to change all the files. I'm actually going to change that extension. And yeah, Python go, yeah. So this was actually, I'm opening O2, which is the most significant bit first. Again, let's go with this, change it to indexed, change the width to the specification for Arduboy 128, and that's it. And you have the flag. You found the flag in the assets, which is congratulations, the flag is CTF Johnny remembers. And that's it. So, yeah, and I actually didn't believe it would work when I was testing this challenge. I was like, yeah, I'm just doing recon, I'm going to take a look at some pictures, maybe this will give me some motivation to continue reverse engineering it. And I didn't have an emulator yet, so yeah. And I started doing this and it actually worked, and I was like, hey, this isn't probably the intended solution. So I pinged the author and he was like, yeah, that's the intended solution, well done, that's an easy task after all. So yeah, there you have it, Johnny boy. Okay, let me take a look if there are any questions, and then I probably should be able to tell you about one more task. This is going to be the hardest task there was, which is called counting. Now, There are two questions actually. Do you have any recommended CTFs or hacking websites to try? If you're a beginner, try Boston Key Party CTF and try Pico CTF. If you're watching my streams from the beginning, then you know that I did some Pico CTF challenges in the past. There is a new Pico CTF from this year, check it out. Let me maybe look it up, Pico CTF 2017. It's created by the Plate Parliament of Pwning, which is probably one of the best, if not the best, CTF teams in the world, so the tasks are pretty awesome, and there's quite a lot of them usually. Yeah, it's already over, so you can register, you can, like, it's just Pico CTF. Yeah. And the tasks are like really entry level, like really simple, and they ramp up to something which you consider easy on a normal CTF. So it's great for the beginners. Yeah, if you're not a beginner, then ctftime.org has everything for you that you need to know. Upcoming events here, Trend Micro this weekend. Then I don't know what this is. Oh, it's also this weekend, then Sequence Site. And I also know that there is Beluminar in China, but it's actually invite only. Actually, my team is flying there, like Dragon Sector, so fingers crossed, please. Yeah. Apart from that, there's also WeChal. I never remember the top level domain, it's .net, okay. And if you go here to challenges, it's like WeChal as in we and Chal, I don't know, maybe from challenges? I don't know. And if you go to, no, sorry, not challenges, to sites. There is a huge list of sites which contain wargaming challenges. Wargaming challenges are similar to CTF challenges, basically, but where a CTF is actually a time-limited tournament, right? That you have like 48 hours to solve the tasks. A wargame is basically a long-running site with, like, continuously running site with challenges being available to test your skills at any point in time. I don't know which one of these I would actually recommend for beginners. I have no idea. I didn't do most of them. I did this one, Security Traps, like actually it was created by the guy who later joined Dragon Sector, Mavekel. Yeah, I would recommend it. It's really fun, so check it out. Okay, so that was one question. Now, try using convert. Oh, this is a nice from Nah. Maybe Nah, I don't know. I'm sorry if I mispronounced your nickname. Anyway, he says, try using convert depth, blah, 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 blah. This would work, obviously. It's convert is from a packet called ImageMagick, which is not anything close to secure, but is a really good converter for images. Yeah. So this would work as well. I'm happy to write a Python script for this usually, because I don't use ImageMagick too much. I have it installed, but I honestly don't use it too much, so I usually write a script for it. Especially that I'm not sure how to do the like least significant bit and most significant bit conversion in ImageMagick. It's probably possible, but I just don't know how to do it. And I would have to look it up, and I could probably write this script faster than I could look it up. Cool. So let's get back to, let's maybe close this window, and let's get back to challenges. So that was Johnny Boy, which was the easiest one. Now counting is the hardest one, I think. In my personal opinion, this was the hardest one. I didn't create it, I created Moon. I might show you the Moon later on. Actually, if you like this topic, we can go through all the other challenges, or at least maybe from Moon and for food next week. But yeah, let's chat about counting, because this was my favorite challenge on the CTF. We actually had a bug in it, but the bug didn't change anything. At least that's my opinion. So you have something called code and something called counter, and you have to download both. Now I'm going to create a new... I'm not going to solve this challenge, I'm going to tell you about this challenge. I'm not going to solve it because it took me hours to solve it. Like 6 hours or something. But it's interesting enough to hear about it anyway, in my opinion. Now, we also should read it. This strange program was found which apparently specializes in counting. In order to find the flag, you need to find the output, I guess, you need to find what the output of counter with this argument is. Now, this tip was, well, not really tip, a clarification was added later. It seems we have, this value is like outside of 32-bit range, obviously. So, and somewhere in the code by accident, we had an cast down into 32-bit range, which was easy to miss. And if you missed it, you could actually solve this challenge anyway and get the correct flag. But we clarified that, hey, actually don't truncate this value when counting the final one. Use the full. That's actually like 33 bits, if I'm not mistaken, 34 bits. So yeah, use the whole 34-bit value. Now, again, there are two files as you've seen. One is called code and the other is called counter. Now, the code, if you go to it in a hex editor, because we'll not know, I'm going to actually launch a real hex editor this time. I'm also going to close this window because I no longer need it. Yeah. So it looks like this. You can see a pattern. This is so obviously that you can see a pattern here, right? So I'm going to minimize it a little. Yeah, this looks better. Maybe even, yeah, this looks even better. Maybe this, or maybe this is already too small. Yeah, but there is like basically a pattern here, right? And the values are quite small with the exception of this, but you have no idea what is it, so let's skip it. But the line length being around 10 hexadecimal is already pretty revealing of what is it, and it's bytecode, like, you know, machine code, but for a virtual machine. So this basically tells us that the counter is a virtual machine. Now it's a 64-bit file, so I'm going to launch it in 64-bit IDA. Yep. Okay, and it's loaded. Here we go. Now we jump to main and we decompile it. And I'm going to tell you what it does. I'm not going to reverse engineering because this file is not the challenge. This file, it's non-obfuscated, it's super small, and it's super easy to reverse engineer. So this is basically, it reads the code file and it validates the input, the code, the bytecode which is there. So we don't care about this function, and then some other function is called. And this is actually parsing the argument, and the argument is passed into something, and this something is passed into this function. And after this function returns, whatever is in this argument is used as the flag, basically. So I think we just have to run it, right? But if I'm going to spell it for you, if we run it, we would have to wait years, and I mean like thousands of years for it to finish. It's an optimize me challenge, actually, not a reverse engineering challenge, or actually both. So an optimize me challenge is a kind of a reverse engineering challenge where you get a program which is super slow and you have to optimize it. You have to first understand how it works and then optimize it, and this is a great example of such a challenge. And I really enjoyed optimize me challenges, to be honest. Now, and this is the implementation of a virtual machine. Now, it's 68 lines. This is not a lot of code. And, well, I know this is decompiled C, right? But even if you look at it in assembly, it's still not a lot of code. And after reverse engineering, which I'm not going to do here, you can find out that there are actually 3 instructions. One instruction is decrement and jump. The other instruction is call a function. And it actually works in a funny way, because there are 16 registers, if I'm not mistaken, which are all 64-bit. And the way it does the call is actually it copies the registers. Like, you tell the opcode how many registers to copy, and then when the call returns, right, how many registers do you want to be restored? So you don't have to do, you know, the standard pushes and pops. And so, yeah, usually, for example, if there's like a call 1, that means store all the registers, and then on coming back, restore all of the registers except for 1, for the first one. It always counts from like error 0. Now, and then there is a third instruction, which was, what was the third instruction doing? I think maybe it was just an absolute jump or something like that. All in all, the instructions were super easy, and then there were only 3 of them. Now I have something somewhere here. My disassembler. So I'm going to show you my disassembler. And I'm going to show you something else. So, not this. Okay, this one. Yeah, this is my disassembler which I've written. I can share it later with you. But again, there are 3 instructions. I called one of them call, because it calls the function, another one of them a loop, and another one of them inc. Well, yeah, right. So one was incrementing and one was looping. Now, each instruction actually took 2 additional arguments, and there were jump targets. So each instruction, each of these 3 instructions was actually also a jump. And they might jump into different regions depending whether the some condition was met or whether it was not met. In this case, the inc actually I think always jumped to the first argument. The loop jumped to the first or the second argument depending on whether the condition, whether the register which is it decremented, because it's like a normal loop in x86. In x86 the loop actually decrements a register and jumps, right? And when the register reaches 0, the loop stops jumping. And this is actually like a similar thing. That's why I named it loop. And the third one was again call, and call had 2 arguments. One argument was the address of the function, and the other argument was where to go after the function returns. So yeah, there you have it. Now what I did is I did at first generate a text file with the bytecode with so this is it. So we see that we have at the beginning a loop, and then we have some increments, and then we have a call, and so on and so on. And this is actually quite readable. But what I decided to do, which you can actually see here, is I decided to make a dot file of it. A dot file is actually a graph, like a text description of a graph. I don't think I have it here, but let me maybe just run the script. Yeah, this. Okay, and it created a graph.file. Here it is. And it's a text description of a graph, and then you can use the, what is it called? I don't remember, but basically dot comment from graphviz packet, that's what it was called, and create a graph. And here we have a graph. Hello. And this is the whole KrzaQ, or actually optimize me, not a KrzaQ and optimize me. This is where we begin. Here. And this is the first loop which we saw. And we saw that it basically goes, well, every node has basically 2 arrows apart from increment. Increment always goes to 1 target, but loop while R0, and R0 is actually, it happens to be the argument which we passed in through the command line. Yeah, maybe I'm not going to show it. So this is actually quite interesting what's going on here, because loop will decrement R0 until R0 reaches 0. So it will decrement whatever we give it in an argument, right? But at the same time, if true, it calls increment R1. So R1 increments while R0 decrements, and so on and so on and so on, until finally R0 is equal to 0, and R1 is equal to what? To exactly what the value of R0 was. So we have so this is basically this simple loop with inc is R0 equals as in an assignment. R1 equals R0, and then R0 is equal 0 because it's zeroed, right, at the same time. So we could disassemble or actually decompile this this block as something like this. Now we have this part, which is basically just increment, 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 and well, it's quite easy. It's actually like assigning, if I'm not mistaken, 1, 2, 3, 4, 5, 6, 7, 11 to R2. So it's just R2 equals 11. And so on. So my methodology when actually reverse engineering this task was to print it on a piece of paper. I actually printed it on an A3 piece. I actually have it here somewhere. I'm going to show it to you. Okay, I'm back. So let's switch to this view, and I'm going to actually reverse the channel. Sorry, the. No, this is incorrect. Alright, I flipped myself because this way you can see the paper. I printed it, this graph, on a piece of paper, and I started basically like going through it. Starting from the leaves. I started from the bottom, right? From the very bottom, from the leaves at the bottom, from the leaf functions. Leaf as in, you know, a tree. And I basically marked all the, yeah, for example, here, you can see this area, which is basically like, there's a circle around it, right? So this, I marked all the functions, like separate functions in their own areas. Like you can see that there are quite a lot of areas here. And then I started reverse engineering, and for example, and basically writing down pseudocode next to it. So here, here, and so on and so on. And I figure out that, hey, this is actually like return true or false, depending on whether R1 is larger than N2, and so on. And it took me a good few hours just like having a pen, a paper, well, this piece of paper, and looking at it and thinking, hey, what does this do? Oh, it's actually a loop that does this, and this is that condition, so this must be a decrement, or this must be a multiplication, and so on. And it took me a good few hours to actually reach a point where I'm not going to say I understood it yet, but where I could transcribe it into Python. And at that point I actually did just that. I transcribed it into Python, and it looked more or less like this. This is kind of a transcribed version in Python. And it's not really a huge version. One thing I noticed actually is that, yeah, it's also noted in a piece of paper, I'm not going to pull it out again, but yeah, I noticed that this part is actually Fibonacci. You know Fibonacci, right? There's a, like, what is the Fibonacci sequence, I believe? And, but it's actually calculated modulo n, modulo some number, and the number was actually, so it was a Fibonacci to the argument which we given, modulo the number calculated by this part. Yeah, basically this part of the block was calculating a modulo and like the value for the modulo, and then this part was called, which was calculating the Fibonacci. So there was the left side and the right side, and the left side was run first, and then the right side, which was run second. So in all honesty, I didn't know, I analyzed it, and it's basically this function. And it's a recursive function. It's actually the recursion is, it's actually these two functions. So for each value, what it did, it ran the above function, and it calculated a sum of the returned values. Now what the above function did is it, somewhat in a recursive manner, which isn't true, it's partly true, but this one is like a linear implementation. It checked whether the value is odd or even, and if it was even, then it actually divided the value by 2. And then, if it was odd, it actually multiplied it by 3 and added 1. So, well, you know you're going to get an even number from this afterwards, right? And then it did this until R1 was larger or equal to 2. So if you, for example, I don't know, put 5 here, right, at the start, well, 5 is odd, right? So we jump here and we multiply it by 3, we get 15, and we plus 1, so we get 16. So this is the second part in the sequence. Then this is actually even, so we divide it by 2, my mistake. So it's 8, this is also even, divided by 2, and we get to 1, which is actually lower than, so we, so we return R2, where R2 is actually the length of the sequence, like how long is the sequence. In this case, it was like 1, 2, 3, 4, 5, 6. Now, it's called the Collatz Conjuncture. Yes, as Game Minds says on the chat, that's the Collatz Conjuncture, and you can read all about it on Wikipedia. I actually didn't know it, and Idolf, who was also testing the CTF and helping with the CTF, he actually told me, hey, that's the Collatz Conjuncture, and like, I have no idea what that is, so I went into Wikipedia. It was already quite late back then, so I just went to Wikipedia, printed the definition, and then I went to catch the train home. Like, I think it was even like the last train or something. So, yeah, CTFs are fun. Yeah, this is exactly it, right? But written in mathematical form. And what you learn basically from reading this is that there is a way to make it faster. There is a way, because you're making a sum of this, which is even sum of these lengths of conjunctures, right? And to do it, you would actually have to cache a lot of results. And the funny thing is that that value that you remember from the challenge description, it was actually 34-bit, right? It was like 9 times 10 to the power of 10. Yeah, give or take, right? So that's quite a lot, but it's still in the, like, you can still calculate it on, like, count to these many numbers on a computer in several seconds. That's not an imaginable number. That's still a pretty decent number. It's like 2 to the power of 34. That's okay-ish. You can still count to it. It's not like 2 to the power of 64. You cannot count to on a modern PC to that number from 0 because it's just too much. Too many numbers. Here you can. So what you have to do is, again, we have this sequence, right? We get some number. For example, we have to calculate this for the number 37. And now 37 is odd, so well, that's not a good example. Let's start with 24 maybe, yeah. And you actually go through the values from 0, 1, 2, 3, and so on and so on. And each time you actually store the result in cache. Now for 24, well, you go this branch, right? So you divide it by 2 and you get 12. And you check, hey, did I already calculate this sum for 12? Oh, I did, because it's a smaller number, so obviously you had to calculate it for it. And I know that the result is, I don't know, I'm going to like lie to you now, 7. So you take 7 and you return it, and then you go to 25 and so on and so on and so on. But by caching the results, you can like have a really quick really quick calculation of it, and by quick I mean 3 minutes, and depending on the optimization you use. Now, there is one small problem here. The small problem is that you do have these many numbers you need to cache. If you have 1 GB of RAM, that's not going to work. These are rather small numbers, and if you read on the Wikipedia, the largest number in this range is actually around, it fits well into 16 bits. So you just use like a 2-byte variable, a short variable for each character, but you still have to have this many of such variables. So this basically says that you have to have, give or take, 90 GB of RAM for it. Well, I do have on my machine actually more than that, but on my work machine I don't. I think I had like 32 gigs, or on the computer I was testing it. So the last numbers I had to calculate, I actually just didn't cache, just brute forced the calculation, and it still worked in under 3 minutes. Well, not under, it was 3 minutes, 10 seconds or something. So yeah, basically the last part is, first of all, calculating this, and this is my code for calculating it. Yeah, as you can see, it's like needs 32 gigs of RAM installed. And yeah, and it runs 3 minutes and it gives you a number. And when you get that number and you put it into Fibonacci modulo something, and this is a code I got from the internet. I don't remember where, it's not my code, I didn't implement it. I didn't want to implement it, so I just got it off the internet. I put the values here, then you run it. Let me run it. GCC fast fib, so that's actually G++. Yeah, you run it, you get this number, and now if you go back to IDA, right? Here, you can see that it actually does a printf of this with this format. So what you have to do is Python, and we use this format, so it's like CTF, and then it's the dot is the same as the dot is the same as 0. Yep, that's it. Okay, and this is the flag. And you submit it and you win. Yeah. And in all honesty, again, I know I didn't reverse engineer this challenge on the live stream, but it took me, I don't know, 6 hours, I think, to solve it, 5 or 6 hours. So it was a great challenge. I really, really recommend you to try it. You don't get to reverse engineer code, quite easy code, for a free instruction architecture too often. So try it. It's a great challenge. I really, really, really liked it. Okay, so that's it. I guess it's already we're closing to getting the end of the stream. So yeah, so let me answer just a couple of questions that you folks might have, and then we'll wrap it up, and I'll show you the mission number 6 at the last stream. So yeah, it's like basically it's like this with reverse engineering and like with hard challenges. You have to spend 6 hours on it, or you have to spend like 10 hours or 20 hours during a CTF. That's normal. Don't be afraid to spend that time. It just requires time. Oh, there are actually like a lot of questions. Okay, so let's go through them. root-me.org has easy and hard tasks. You should try it. Let's see. I apologize that you cannot paste links into the YouTube chat. I tried to configure it in a way that that actually would allow you to paste links, because I have an active moderator, right? So if there is anyone abusing the links and spamming some random stuff, the moderators would take care of it. Thank you, KrzaQ, again for being here, and thank you to my all other moderators for helping me. So I'd like you to be able to paste links, and you cannot. I'm sorry. It's just out of my power. Now, this is root-me.org, and it said I'm going to give you a link on IRC and as well on here. So, yeah, try it out. It looks like a fun wargaming. So, well, I don't know if it looks like fun, but there are 265 challenges, so they're bound to be a fun challenge in there, and I'm pretty sure there are more than one fine cool challenge. So one series I'm thinking about making is actually finding a random wargaming task and doing the first 3 levels, and not all the levels, because usually the wargaming sites say in the rules that please do not publish solutions. So I'd probably reach out to the owner of the website and say that, hey, let me do like 3 random tasks on my stream. Maybe it will be good advertisement for your platform if they're fun, and maybe they will allow me, and then I can actually do it. So that's just an idea I have in my mind. Yeah. So okay, so that was one comment. Seesaw is also a good beginner CTF. I fully agree. Seesaw is like, can I write here? I'm not sure if you can understand my writing, but yeah, this is also a good entry level. I'm pretty sure I mentioned Boston Tea Party, right? But that's also pretty fun. My attempt to solve counting, and Vesim from Vesim. Vesim is in the just hit the core team. Yeah. So okay, I would. Oh, okay. So it's what Vesim is doing here. I think I saw this code already on my channel, on my IRC channel. This is a transpiler. This is actually transpiling it into. I have absolutely no idea what is this. What is this? Is it D? I don't know. But it's transpiling it into a different language, and maybe then the optimizing compiler will handle everything, and it will work like that. That's a good approach. I don't know. Vesim, did it work actually? If you could tell me. Were you managed to solve this challenge this way? Okay. Can't you use symbolic execution for this? This is a very good question. No, because of the modulo operation. That's my guess. But I'm not an expert in symbolic execution or stat solving or anything like that. My guess is that you probably would not be able to solve it due to the modulo operation. That's what smarter people tell me usually when I have stuff like this. I might be mistaking, it might be solvable by symbolic execution. Pwnable.kr. It's something that GeoHot or George Hotz was solving on where is my browser? Yeah, on YouTube, or was it Twitch or something? Yeah, Pwnable.kr. I've heard this name before quite a lot of times, so check it out. I'm going to give you the links as well. VM Master, thank you for the link. I'm sorry, I forget to usually mention who is giving the question. I'm sorry, my apologies for that. I'm trying to make a habit of it, but I usually forget, sorry. If you don't know, GeoHot is the person who actually went to an offline final CTF himself and won it. So, yeah, GeoHot is quite amazing, in all honesty. Okay. Is there a way to run a sub-process with full control over it in C++ in a short manner, code-wise? Not that I know of in a short manner. You can write a debugger, but that's usually like 100 lines of code. I've done it a couple of times, and I usually try to script debuggers instead of writing my own debugging code, but yeah, that's the only way that comes to my mind in C++ that you can do it. Unless you find a library which does it for you, obviously. That was a question from Der Besserweiser. Or Besserwieser, actually. Okay, the Best Indian Hacker asks, CTF web pages in scope of Google VRP? No, it wasn't in the scope of Google VRP. Did you find any bug on it? But it was in the scope, as far as I know. You can also try hackthebox.u. Let me open it here. Yeah, there's some animated stuff, so it has to be good. I'm going to give you a link again. Okay, this link is from Panagiotis Papantonioi. I'm sorry, I totally butchered your name. My apologies. Okay, Vesim says that no, his transpiler either didn't work or didn't find the solution, but it's a good approach. Okay, I think I went through all the questions. So again, thank you KrzaQ for being my moderator today. No, I have it flipped, so he's here. Yeah, okay. And let me know if you would like me to continue with Google CTF on the 2 other reverse engineering challenges or 3 other reverse engineering challenges in the next week, or if you would prefer me to do some other topic, let me know in the comments down below. And good luck with mission number 6, and I leave you to it. So yeah, so have a nice evening, happy hacking, and see you next week. Goodbye.